On the eve of the most important day in physics, we ask, who truly redefined our reality? One was born on March 14, 1879. The other left us on March 14, 2018. Albert Einstein changed how we see time and space. Stephen Hawking pushed our understanding beyond the edge of the universe. This isn't about who was greater. It's about how two minds, separated by time, reshaped how humanity thinks about reality itself. We often remember great thinkers by their discoveries, but what's easy to forget is when they lived and what kind of world shaped their thinking. Albert Einstein didn't just appear with revolutionary ideas. He grew up in a world still governed by Newton, certainty, and classical rules. Stephen Hawking didn't inherit that same universe. He entered a world already shaken by Einstein's ideas, a universe full of unanswered questions, paradoxes, and edges science hadn't crossed yet. They weren't solving the same problems. They weren't standing at the same starting line. To understand how they reshaped reality, we first need to understand where each of them began and how their journeys into the unknown unfolded. Back in 1879, in the quiet city of Ulm, Germany, Albert Einstein was born into a world that believed it already understood reality. Physics felt complete. Newton's laws ruled motion. Time was absolute. Space was fixed. The universe seemed predictable. This was the world Einstein grew up in. But Einstein was never comfortable accepting ideas simply because they were established. He questioned authority, routines, and rules that demanded memorization without understanding. School didn't suit him, not because he lacked intelligence, but because he wanted meaning, not repetition. After graduating, Einstein didn't enter a famous laboratory. He worked quietly as a patent clerk in Switzerland, far from academic prestige. And in that quiet space, something rare happened. Free from pressure and expectations, Einstein began to imagine. What if you could ride alongside a beam of light? What if time didn't move the same for everyone? What if gravity wasn't a force, but the shape of space itself? These ideas didn't start with equations. They started with mental pictures. Einstein used thought experiments to understand reality intuitively, and only later turned to mathematics to describe what he already saw in his mind. Then, in 1905, still largely unknown, he published papers that quietly changed physics forever. Time could slow down, space could bend, energy and mass were the same thing. Reality was no longer fixed. Einstein didn't just add new answers, he changed how science asked questions. And once reality itself became flexible, a new frontier of mystery opened, waiting for the next mind to explore it. A generation later, in 1942, in Oxford, England, Stephen Hawking entered a very different universe. By this time, Einstein's ideas had already transformed physics. Time was no longer absolute, space was no longer fixed. Reality itself had become uncertain. This was the world Hawking inherited. From an early age, he was drawn to the deepest questions, not just how the universe works, but how it began and how it might end. Where Einstein relied on intuition and imagination, Hawking leaned towards structure. He loved mathematics. Equations were his language. Precision was his way of navigating the unknown. Then, in his early 20s, Hawking was diagnosed with a rare motor neuron disease. Doctors told him he had only a few years to live. His body began to weaken, slowly and relentlessly. But his curiosity did not. As his physical world narrowed, Hawking's intellectual world expanded. He focused on the most extreme edges of reality: black holes, the beginning of time, and the limits of space itself. Where Einstein showed that space and time could bend, Hawking asked what happens when they collapse completely. Through mathematics, he revealed that black holes were not eternal prisons. They could emit energy, lose mass, and eventually disappear. It was a radical idea, one that challenged how we understand the universe. Hawking didn't explore reality through movement or experiment. He explored it through thought, equations, and persistence. And by sharing those ideas with the world, he reminded humanity that even under the greatest constraints, the human mind can still reach the furthest frontiers of existence. Albert Einstein believed that understanding reality had to begin in the mind, not on paper. Before equations, there were pictures. Before formulas, there were questions. Einstein didn't start by calculating how the universe worked. He started by imagining it. He asked questions that sounded simple, almost playful. What if you could ride alongside a beam of light? What if time didn't pass the same way for everyone? What if gravity wasn't a force at all, but the shape of space itself? These weren't mathematical problems at first. They were thought experiments, mental movies that allowed Einstein to explore reality intuitively. For him, imagination wasn't decoration, it was the engine. Einstein believed that if an idea couldn't be visualized clearly, it wasn't truly understood. Mathematics came later, not to discover the idea, but to describe what the imagination had already revealed. That's why his breakthroughs didn't feel incremental. They felt revolutionary. By trusting imagination first, Einstein made the invisible visible. He turned abstract concepts like time dilation and curved space into ideas the human mind could grasp. In doing so, he didn't just change physics, he changed how we think about understanding reality itself. And that way of thinking, starting with intuition, curiosity, and imagination, would become the foundation for everything that came next. Stephen Hawking believed that imagination alone was not enough to understand reality. There were places intuition could not reach, places the human mind could not picture. So Hawking trusted something else. He trusted mathematics. Where Einstein began with mental images, Hawking began with equations. He believed that when reality becomes extreme, when time breaks down and space collapses, mathematics is the only reliable guide. Equations, to Hawking, were not just tools. They were windows into truths no experiment could directly observe. Black holes could not be seen. The beginning of time could not be replayed, but mathematics allowed Hawking to explore these realms with precision. Instead of asking what it feels like to experience reality, Hawking asked what must be true if the equations are consistent. This way of thinking led him to discoveries that intuition alone would never suggest, including the idea that black holes are not eternal, but slowly lose energy and disappear. For Hawking, mathematics wasn't cold or distant. It was a form of clarity. As his physical world narrowed, mathematics gave him freedom, allowing his mind to move where his body could not. He showed that even at the edges of existence, where imagination fails and observation ends, logic and mathematics can still illuminate the unknown. And through this approach, Hawking didn't just extend Einstein's universe, he pushed it to its absolute limits. Albert Einstein and Stephen Hawking both reshaped our understanding of reality, but they didn't do it in the same way, and they didn't arrive at their ideas through the same kind of thinking. Their differences weren't about intelligence, they were about approach. To understand how two minds could change the same universe so differently, we need to step back and look at their work across a few key dimensions. So instead of asking who was greater, we're going to break this down across 5 areas, 5 ways their thinking, constraints, and impact diverged. And through those differences, we'll see how both of them reshaped reality in their own way. First, let's talk about how they think. Albert Einstein believed understanding reality began with imagination. He pictured ideas in his mind first, using thought experiments to see how the universe might behave, and only later used mathematics to describe those ideas. For Einstein, intuition came before calculation. Stephen Hawking, on the other hand, trusted mathematics more than intuition. He worked from equations outward, using logic and precision to explore parts of the universe the human mind couldn't easily visualize. For Hawking, calculation came before imagination. One made reality thinkable, the other made reality calculable, and that fundamental difference in thinking systems shaped everything that followed. Now, let's talk about how they redefined reality itself. Before Albert Einstein, reality was seen as fixed and absolute. Time moved the same for everyone. Space was constant. Einstein changed that by showing that time and space depend on motion and gravity. Reality wasn't rigid, it was relative. Stephen Hawking took that flexible reality even further. He explored what happens when space and time are pushed to their limits, inside black holes and at the beginning of the universe. Where Einstein bent reality, Hawking questioned what happens when it breaks down completely. Together, they didn't just update our understanding of the universe, they redefined what reality could be. Next, let's look at the limits and constraints they lived with. Stephen Hawking faced extreme physical limitations early in his life. As his body weakened, his ability to move, speak, and interact with the world steadily disappeared. But those constraints didn't shrink his thinking, they sharpened it. As his physical world grew smaller, his intellectual world expanded to black holes, the beginning of time, and the edges of reality itself. Albert Einstein, by contrast, lived with physical freedom. He could travel, debate, teach, and explore ideas openly. His constraints were different. He had to challenge deeply rooted beliefs and convince the world to let go of certainty. One was limited by the body, the other by tradition. And in very different ways, those constraints shaped how each of them changed our understanding of reality. Now let's talk about their legacy and impact. Both men made a huge mark on science, but in very different ways. Albert Einstein changed the foundation. After him, physics could no longer see time, space, or energy the same way. Entire fields were rebuilt because of how he reframed reality. Stephen Hawking didn't rewrite those foundations. He tested how far they could stretch. He took Einstein's universe to its extremes, exploring black holes, time's beginning, and the limits of existence itself. Einstein transformed how science thinks. Hawking transformed how far science dares to go. And together, their impact isn't just progress, it's a deeper, more honest map of reality. Finally, let's talk about science as a human story. Beyond equations and theories, both men changed how people connected with the universe. Stephen Hawking showed the world that curiosity could survive even under the greatest physical limitations. Despite losing his ability to move and speak freely, he invited everyone to explore black holes, time, and the origins of the universe alongside him, proving that science belongs to everyone. Albert Einstein, on the other hand, made science feel intuitive. Through imagination and thought experiments, he helped people picture complex ideas, turning abstract physics into something the human mind could grasp. They didn't just change what we know about the universe, they changed how people engage with it, and that human connection may be their most enduring legacy of all. Albert Einstein and Stephen Hawking didn't compete to redefine reality. They did it in different eras, under different constraints, and through different ways of thinking. Einstein taught us to imagine the universe differently, to question what feels obvious, and to trust intuition when certainty fails. Hawking taught us to confront the universe mathematically, to push logic beyond intuition, and to explore realities we may never fully visualize. One made reality thinkable, the other made it calculable, and together, they remind us that progress doesn't come from one kind of genius, but from many ways of thinking, questioning, and exploring the unknown. On the eve of a birthday and a remembrance, this isn't about who changed reality more. It's about how both minds reshape the way humanity thinks about reality itself. As we commemorate these two geniuses, Albert Einstein and Stephen Hawking remind us that there isn't just one way to understand the universe. Progress comes from imagination and precision. You don't need to think like Einstein. You don't need to think like Hawking. But learning how they thought can change how we approach the unknown. Now tell us, what did you enjoy most about this breakdown? Or is there another story you think we should explore next? Let us know in the comments below. If this made you pause or rethink how ideas actually move the world, please subscribe to Best Version. And if you're not going anywhere yet, click here and continue watching.